the May 2022 IEB past paper. This is the supplementary paper. We'll be going through the section A of paper 2. So we'll just be doing the first 6 questions. So section A, question 1. The question says a straight line goes through P, 2, and 9, and Q is 6 and 17. Determine the gradient of the line PQ. Now, to answer this, we need to use the gradient formula. Now, normally the gradient formula looks like this. We can write it as the gradient of PQ is equals to okay, so substituting those values as the y for P and the x for P, the y for Q, the x for Q, you're going to get so the gradient of PQ is equals to 2. Now, for the second question, it says if P, Q, and W, which is negative 6 and T, are collinear, what is the value for T? So a collinear line is a line where 3 points are on the same line. So on this line, it doesn't matter the order, you have P, you have Q, we'll have W. And all this here, this line will have the same gradient. So we can say the gradient of PQ is equals to the gradient of QW, which is equals to the gradient of PW, right? Because it's on the same line. So now we already have the gradient of PQ, which is 2. So we can just use the coordinate. Let's say we take this one here, the gradient of QW, which you also expect it to be 2. But now using the gradient formula, which we used over here, we could say that this here would be, now Q is 6 and 17, okay? Okay, so this would be 17 minus T over the x's, that would be 6 minus 6. So this would give you 12, 24 is equals to 17 minus T. So I move this over, I'll get T is equals to negative 7. So your final answer would be T is equals to negative 7. That's it. Now, question 3 says, find the equation for the perpendicular bisector of PQ. Now, they kind of define what a perpendicular bisector is. It is a line, a perpendicular line to PQ that goes through the midpoint. So to answer this question, we want to find the equation of our perpendicular bisector, which is a straight line. Now, any straight line needs to look like this. Y is equals to mx plus c. So to find this straight line, I would need to get the gradient, and I also need to get a coordinate, right? A point. Now that point will help me find the equation of the line. So let's start with getting the coordinate. Now, since it is the midpoint of PQ, so let's represent the midpoint of PQ as D. So we can say that XD is equals to XP plus XQ divided by 2. And for YD, it can be written as YP plus YQ divided by 2, right? So this is the formula for the midpoint. So substituting these two values, you're going to get 2 plus 6 divided by 2. And in this one here, you're going to get 9 plus 17 divided by 2. 2 plus 6 is 8, divided by 2, you get 4. So that's the coordinate. And this is 9 plus 17 is 26. 26 divided by 2 is 13. Okay, so the midpoint of PQ is there. So we have a coordinate. And the next thing we also need to figure out is the gradient. Now, because it's a perpendicular bisector, we understand that the product of the gradients of perpendicular lines normally multiply to give you -1. So if the original gradient of PQ was 2, we would understand that the perpendicular line will just be -1/2. Okay, so now we have the gradient, we have the coordinates, we can put into the equation. So I'm going to use this equation over here. Y minus y1 is equals to mx minus x1. So you have y minus 13 is equals to -½ x minus 4. So simplifying this here, you're going to get y is equals to -1/2x. This here will give you 2. That moves over, you get 15. The equation of the perpendicular bisector of PQ is -½ x plus 15. And that's it. Now question 4 says if a point H, which is 14 and y, lies on the straight line with an equation of 4y minus x is equals to 2, then what is the length of PH? Now our coordinate of P is 2 and 9. Now they tell you here that H, this coordinate of H, you have the x coordinate of H, but you don't have the y. Since you have the equation in which H is on, it can help you get the y. So what I'm just going to do is substitute this 14 in there. So this would be 4y minus 14 is equals to 2. So therefore, y is equals to 4. Okay, so the actual coordinate of H is 14 and 4. Now they're asking you for the length. And whenever you're trying to find the length, it's actually asking you for your distance, right? So we're going to use a distance formula. So distance is equals to, the formula for distance is x1 minus x2 squared plus y1 minus y2 squared. So substituting this in, you will have okay, this is 12, 144, 25. This whole thing here will be 169. So your distance is 13 units. And that's it. So for question B, it says in the diagram below, AB has a gradient of 5. Okay, so let us fit in what we're given. We're told here that the gradient of this line over here is equals to 5. Now they also tell us here that the equation of AC is 2y minus x plus 1 is equals to 0. Now, it's best we rewrite this in the default form of a straight line, which would actually look like this. 2y is equals to x minus 1, so y is equals to 1/2x minus 1/2. Okay, so we would also say that the gradient of this here would be m is equals to 1/2. Okay, so they ask us to calculate the size of theta. Now, whenever you're asked to find an angle and you're given gradient, the best thing to do is use angle of inclination, right? And the formula for that is m is equals to tan theta. Now, we understand that the angle of inclination we can get is anti-clockwise from the x-axis, so meaning that this is an angle of inclination we could get, that's this one here, which I would call A. And we could also get another angle of inclination of this line AB, which I'm going to call B. Okay, now we're asked to find theta. Now from this, we would understand that theta, right, is actually B minus A, because this whole thing is angle B, and this little piece here is angle A. So if I subtract B from A, it should give me this theta that we have here. So before we find our theta here, let's rewrite this equation in terms of the angle. So the angle can be equals to the second function of the gradient. Okay, so for B, I could actually write it as tan the second function of the gradient, which is at B, which is 5. And for the second one, which is A, it will be tan the second function of half. And that there will give me the theta that you want. So I could say theta is equals to, let's put this in our calculator, 78,69 minus, then for half, 26,57, 26,57. And to actually get theta, I just need to subtract. So theta would be 52,12. 13. So theta will be 52,13. Okay. So question 2. Now this question says, given that fx is equals to 3 sine x minus 45 and gx is equals to 2, sketch the graph of fx and gx on the set of axes below x is an element of negative 45 to 360 degrees. Okay. So I think the first thing we can draw is the gx because it's a very simple graph. All we just need to draw is a horizontal line passing through y is equals to 2. Okay, so this is your graph. That's it. Okay, now for fx, it needs a little bit of work to get this. Now we understand that the amplitude has been increased to 3, right? So every single one of your value can be multiplied by 3. And not only has it been increased to 3, we also understand that it has been shifted 45 units to the right. To draw the second graph, what we need to put at the back of our mind are important points. So things like 0, 90, 180, 270, and 360. And that's what I'm going to be working with. Okay, so because this graph says 3 sine x minus 45, we understand that it has been multiplied by 3 due to the amplitude, and it has been moved 45 units to the right. Let's start with the first one, sine 0. Normally, sine 0 is 0, but because you have a 3, you multiply it with a 3, which still gives you 0. But now you're moving it 45 degrees to the right. It means that the coordinate would actually be 45 and 0. Okay, now we go to the next one, 90. 90 is normally, sine 90 is normally 1. Okay, now multiplying it by 3 means that it would be positive 3. But now we're moving it 45 degrees to the right. It's going to go to 135. So it will be 135 and 3. Okay, going on to the next one, we have 180. 180 is usually 0. Multiplying by 3, 0. Move 45 degrees, meaning that 225 is 0. Then we go to 270. So normally you have 270 as negative 1. Now multiplying by 3 means that it goes to negative 3. Moving 45 degrees to the right means I'm going here to 315, which is that there. Now on the negative x-axis, right? So if you put in your calculator, sine negative 90, sine negative 90, as you can see, it gives you negative 1, but we're multiplying this by 3, which will mean that it is negative 3. But we now need to move our graph 45 units to the right, so it becomes negative 45 and negative 3, which is there. So let's try to get our y-intercept, right? So we know where it's going to cross our graph. So the y-intercept is we substituting x as 0. So we have 3 sine 0 minus 45. Close the bracket. Okay, so this is negative 2.12. So it's in between 2 and 3. Okay, so our y-intercept is just very close to this, which is maybe somewhere around here. Okay, so now we can connect our graphs. This is how it's going to look. this here should be your graph. Now for B, it says determine correct to one decimal place. The value for x is an element of -45 to 360, satisfying fx is equals to gx. Now they're actually saying our two equations are equal, right? So we are saying this, that the equation of fx, which was 3 sine x minus 45 is equals to 2. Okay, so simplifying this one here, this is what it's going to give you. Okay, so now we need to get the reference angle. The reference angle would be so that is 41,8. So the reference angle is 41,8 degrees. Okay, now sine is positive in two quadrants. It's positive in the second quadrant and positive in the first quadrant. So let's start with the first quadrant. So in the first quadrant, which I'm going to show here, I'm going to say that this here is x minus 45 is equal to the reference angle, which is 41,8. And because it is finding the general solution, we have to add plus k360. And with this, you're going to get x is equals to, moving that over, plus 45, 86,8. 86,8 plus k360. So for the second quadrant, we could also write the same thing. X minus 45 is equals to 180 minus theta, which is 41,8 plus k360, right? So we just need to substitute this in there. You're going to get x is equals to, so it's 180 minus 41,8, then add 45. 180 okay, so this is 183,2. So this will be 183,2 plus k360. Now, since we want our answers between -45 and 360, all we just can substitute for our k is 0. So our answers will be x is equals to 86,8 and x is equals to 183,2. So it needs to kind of make sense in our graph. We are looking for where fx and gx intersect. As you can see, this is the graph of gx, and this is the graph of fx. They only intersect twice. They intersect here, and they also intersect here. Now, this, as you can see, is 90 and is very close to 90, so it makes sense if this is 86,8. And this one here is just a little bit after 180, so it also makes sense if it is 183,2. Now, the last question now asks, for what values of x is x an element of -45 to 360, where fx is greater than gx? Now, what this means is, where is fx above gx? So where is this our fx graph above the gx over here? Now, as you can see here, from the point of intersection, the blue line, which represents our fx, becomes above the gx until the second point of intersection, where it is now below it. So we can say from 86,3 to 183,2, the fx is above the gx. Our answer would be x is an element of 86,8 and 183,2, right? You can write it like this, or you could obviously write it like this. Now, either one of them is absolutely right, and that's it. So moving on to the next question, which is question 3. Now, A says, which is question 1 under A, prove that cos 2 theta plus 1 over sine 2 theta plus tan theta is equals to 1 over sine theta cos theta. Now, with questions like this, we are trying to make the left-hand side equals to the right-hand side. It could also be vice versa. You could try to make the right-hand side equals to the left-hand side. But because it looks like you have more information in the left-hand side, I'll recommend we work with the left-hand side and try to simplify it, okay? We have some double angles over here. You can see cos 2 theta is a double angle which can be rewritten. We have sine 2 theta is also a double angle, we could also be rewritten. We also have tan theta is an identity, right? Tan theta is sine theta over cos theta. So those informations are important, okay? So I'm going to use cos 2 theta. I'm going to say it is equals to 2 cos square theta minus 1 for sine 2 theta, 2 sine theta, cos theta, and finally for tan theta, I am going to use sine theta over cos theta. Okay, so if I'm putting these values in, I have 2 cos square theta minus 1 plus 1 over, and for the other side, I'm going to have 2 sine theta cos theta, then plus sine theta over cos theta. So simplifying this, you'll get 2 cos square theta over 2 sine theta cos theta plus sine theta over cos theta. Okay, now since we have cos square theta here, which actually means cos theta times cos theta, one of these cos thetas can cancel out the cos theta in the denominator. And this 2 we have here could also cancel out this 2. So that will mean that you only have cos theta over sine theta plus sine theta over cos theta. Okay? Then since this is a fraction, we can calculate our LCD and simplify it. The LCD for this fraction would be sine theta cos theta. So we have sine theta cos theta. In the numerator here, you have cos square theta, and this other numerator here, you're going to have sine square theta. Now, cos square theta plus sine square theta is another identity, and that actually gives you 1. So this here would be 1 over sine theta cos theta, okay? Which is exactly what this guy's wanted over here. So we proved it. That's it. Now, question 2 says determine the value for theta if theta is an element of 0 and 90, for which the identity is not valid. Now, for an identity not to be valid, if you do have a fraction, it means that the denominator has to be equals to 0. Because if this denominator is equals to 0 and you divide, right, by 0, you would always get an undefined answer. On your calculator, it gives you like a math error. Okay, so for this here, all we just need to do is take the denominator. We can just take sine theta cos theta. We could also take the sine 2 theta, but let's just take one of this. Let's take the other side. So we'll say sine theta cos theta is equal to 0. Okay, so for this not to be valid, it is sine theta times cos theta is equals to 0. They want our answers to fall between 0 and 90. So what this means is sine theta is equals to 0 or cos theta is equals to 0. But what would be the theta value? This here, theta would be equals to 0. And for the cos graph, cos 90 is usually equals to 0. This theta here would be 90. Okay, that's it. So B says ABC has side lengths. AB is 3, BC is 9, AC is 10. Calculate the size of A. Now, whenever you have 3 sides and no angle, we normally use cos rule. Now, right, it's like a rewritten form of cos rule. So the formula we're going to use to answer this question would look like this. The cos of A is equals to B squared plus C squared minus A squared over 2BC. Okay, so obviously this represents your B, right? The side that faces the angle B. This represents your A, the side that faces angle A, and this now represents your C, the side that faces angle C. Okay, so substituting the values you have, so substituting this in your calculator, so now to get your angle A, all you just need to do is move the cos over to the side, so it becomes a reciprocal of 7/15, and that gives you 62,18 degrees. Okay, that's it. C asks us to calculate the area of ABC. Okay, now that we have this angle, which is 62,18, we can calculate the area of this triangle. Now, since there is no perpendicular height, we could use the area rule. The area rule says that using the values that we have, okay, so so the area of this can be written as half AB AB times AC, right? Sine angle A. Okay, so it's kind of like an included angle. So it is AB and AC, and the angle in between those two lines. Okay, so this values will be half 3 times 10, and the sine A part here is sine of 62,18. Okay, so substituting this in. So the area will be 13,27 units squared. Okay, and that's your answer. So question 4. A says prove the theorem that states the angle subtended by an arc at the center of a circle is 2 times the angle that is subtended at the circumference by the same arc. Okay, so literally what we're trying to prove here is we are saying that if this is x, this is 2x, right? That's what we're trying to prove, right? That the angle at the circumference is twice the angle at the center, which is subtended by the same arc, right? And this here is your arc, right? So this arc CB creates O and also creates that angle A, okay? So we're required to prove that, as I said, COB, the angle O, is equals to 2 times CAB. Now we need to make some constructions to prove this. And the construction we're going to do is draw a straight line that goes from A and goes through O, right? So you're just going to draw a straight line more or less like this, okay? And we can try to label them. We could say that this here is 1, this here is 2, so that represents A1, A2. This here could be O1, and this here could be O2, right? So the construction that we're making is on AO. Right, so we draw a line from A down to O. Okay, so let's get into the proofs. Now, the first thing that we could say is angle A1 plus C is equals to O1. Now, we can say that this angle A1 plus this C is equals to O1. The reason why we could say that is that that's exterior angles of a triangle. right? So the exterior angles of a triangle is equals to the opposite sum of interior angles. So A1 plus C gives you that. Now, another thing that we also do know is that angle A1 is equals to C. Now, the reason is because OA and OC are radiuses, which therefore makes this triangle OAC an isosceles triangle. Okay, so we could say that A1 is equals to C. The reason for that is an isosceles triangle, and therefore it would actually mean that 2A1 is equals to O1, okay, for this triangle. Now, this triangle OAC is similar to triangle OAB. Now, if that's the case, we could say similarly, 2A2 would be equals to O2, right? So we'll do the exact same thing. We'll start with the fact that A2 plus B is equals to O2. We would also say that A2 is equals to B, and therefore you can now say A2 is equals to O2. Now, since without going through all the stress, we could just say that since those two triangles are similar, we can say similarly, this is also true. Okay, so now we combining these two statements, we could say that 2A1 plus A2 would be equals to O1 plus O2, right? And this part here is the same thing as your CAB. And this part here is the same thing as your COB, right? Exactly. And that's exactly what we're required to prove, which we just did over here. That's it. So for B, it says in the diagram below, circle center O is drawn, and C, D, E, F, and G lies on the circumference of the circle. We're told here that EGF is equal to 36 degrees, CED is equal to 50 degrees, DCE is equal to 22, ECO is Y, and OCF is X. Now, each and every one of this information is on our diagram over here. So the first one was to calculate the value for Y, right? We're trying to get this Y value. Okay. Normally, whenever I deal with questions like this, I try to get the answers first, then I can now write the reasons and everything involved. Okay. So looking at this here, the first thing I see is that if this is 50, this here is 100. And it is 100 because of angle at center is equals to twice angle at circumference. Now, we also see that OC and OD are both radiuses, which will make OCD an isosceles triangle. And that would also mean that the angle here will be 40 and this angle here will be 40. The reason why I can say that is because sum of angles in a triangle makes up 180, right? And these two angles has to be equal so that you can have a total of 180, right? So it is 100 minus 180, which is 80 divided by 2. So they will both share 40 degrees. But finally, to get your value for y, I would understand that this one here would be 18. How I know it is 18 is because, so since this total is 40, I just need to subtract 40 from 22 and it gives me 18. Okay? And that will be your answer. Now, let's put all this in words because we need to write it out properly. So I'll start with the fact that COD is equals to 2CED. And as we know, that's 250, which is 100. And the reason for that is angle at center is twice angle at circumference. Okay, so the next statement I'm going to make is D2 is equals to OCD, and the reason for that is an isosceles triangle. Okay, because they both have the same radius, and I can now say that OCD is equals to 40 degrees, and the reason for that is sum of angles in a triangle. Okay, and therefore y will be equals to 40 minus 22, which makes y equals to 18 degrees. Okay, so that's exactly how I went about getting this my values. Now the next question says determine the size of x with reasons. Okay, so now to get x, I also see that angle G here, which is FGE, is equals to FCE. Now the reason for that is this, right? Look at that. That is your bow tie. This is angles in the same segment. And if that's the case, this is 36 and this will be 36, which would also make x 18, right? Because they have to add up 18 plus 18. That's also 36. Okay, so let's try to put all this in writing. So determine the size of x. So the first thing I'm just going to write down is FGE is equals to FCE. FGE is equals to FCE, which is 36 degrees. And the reason for that is angles at the same segment. Okay, so it will mean that, therefore, angle x will just be 36 minus 18 degrees, which is 18 degrees. And that's it. So moving on to the next question. C says in the diagram below, the circle center O is drawn. N, R, J, L, K are points on the circle. You are told that Ln and Rk are diameters, right? So this line and that line. We're also told that Ln intersects Jk at M such that Jm is equals to Mk, Jm is equals to Mk. So that would actually mean that M is a midpoint, okay? If Jm is equals to Mk, M is a midpoint. We're also told that Jr, which is 5, is equals to Ro. So now that kind of tells us that that's the radius, right? Because Ro is a radius, so every single radius will be 5. This is what this information tells us, right? That is your radius. Okay, that would definitely come in handy. So the first question was to determine with reason the length of JK. So we want to try to get JK, this one here, the whole length over here. So since we know that JR here is 5, and we've also been told that the radius is 5, and since RK is a diameter, we could just say that this whole length is 10. Now another information that we also know is that since this is a diameter, this J1 and J2 has to be 90 degrees due to angles in a semicircle, right? So using Pythagoras, it will definitely help us get the entire distance of JK. Okay, so that's exactly what we're going to do to get this particular question. So to write all this down, the first thing we're going to say is J1 plus J2 is equals to 90, and the reason is angle at a semicircle. Okay, now because of that, we understand Pythagoras can be used, right? So we could just say, since we're trying to get JK, right? We could just say JK squared is equals to the hypotenuse, which is RK squared minus the other side, which is JR squared. Okay, so this is just 10 squared minus 5 squared is equals to JK squared. Okay, so let's just put all that in the calculator real quick. So it will be 10 squared minus 5 squared. So that's 75. So it's just the square root of 75. Okay, so we could say that JK is equals to the square root of 75. Yeah, and that will be your answer. Now the next question here says determine with reason the length of ML. So they want the length of this one over here, which is ML. Okay, let's clean this 10 because we don't really need the whole 10 anymore. Okay, so they want the length of ML. The problem with ML is that there's no way to calculate ML on its own. However, we could actually calculate the length of OL. Now we can calculate the length of OL, or actually we know the length of OL, because that's a radius, right? So this is a radius, and this here is also a radius. Okay, so the whole length of OL is 5, and the whole length of OK is 5. Now, for me to calculate the value for ML, I'm thinking I should try as much as possible to get the length of MO. Because if I can get the length of MO or OM, I can subtract it from 5, and it gives me my value for ML. Okay. Now, another thing we could also look at here is that since this is the center of your circle, and whenever you draw a line from the center of the circle to the midpoint of a chord. Now, we know this is a midpoint because I kind of talked about it before. They told us that Jm is equals to Mk, right? So if it's a midpoint, that's the theorem 1. It is usually perpendicular. So this is actually 90 degrees. Yeah. So I actually have the value from Mk, right, which is root 75 divided by 2, right? I have the value for OK, which is 5. I could figure out the value for OM, okay, using Pythagoras. Then when I get that answer, I subtract it from a total of 5, and it gives me my value for ML, right? And that's exactly how I'm going to go about answering this question, okay? So let's get into it. So the first thing we're obviously going to say is we need to talk about O2, right? So we'll say O2 is 90 degrees, okay? So we know that O2 is equals to 90, and the reason is line drawn from center to midpoint of a chord. Yeah, so that's just literally your theorem 1. Now, since JK is root 75, we also know that MK would be root 75 over 2. Okay, so now we're just going to use Pythagoras for OMK, right? So I'm going to say, so what do I want to get? I want to get OM, right? So I'm going to say OM squared is equals to OK squared minus, right? OK squared minus MK squared. OK squared minus MK squared. Now, OK squared is 5 squared minus this one here, which is root 75 over 2 is equals to OM squared. Okay, so putting this in your calculator, 5 squared. Sorry, by the way, there's a squared here that I didn't put. Okay, yeah, so 5 squared minus bracket the root of 75 fraction, put a 2 there, squared of that. That will give you 25 over 4. Now we square root this answer, that will give you actually OM. That's 5 over 2. Okay, so it actually means that OM is equals to 5 over 2. Now remember what we said before, that the entire length of OL is 5, right? And now we just calculated the OM to be 5 over 2. So to get ML, we just need to subtract that from 5. So we could say that ML is equals to 5 minus 5 over 2. So that's 5 minus 2.5, which is also 2.5. So ML is also 5 over 2. And that's your answer. That's it. Diagram below, triangle ABC is drawn. E is a point on AC and D is a point on BC, with AB parallel to ED, right? So we are saying that this line AB is parallel to ED. We're also told that F is a point on ED and G is a point on EC such that FG is parallel to BC, right? FG is parallel to BC. Yes, BC. Okay. Now, AE is 4 units. There you go. BD is 3 units. There you go. DC is 9 units. Now, we also told that EF ratio FD is 2 to 1. Now, this is the only information that wasn't given that I think I can try to represent. They told us that the ratio of this is, take for instance, like saying 2K, 1K, right? That is your 2 to 1. Okay. Now, the first question says, calculate the length of EC. Now, we are trying to get EC, this entire length over here. Okay, this whole thing over here is what they want us to get. Now, to get this, I want you to focus on triangle CAB. Okay, so focusing on this here, we would understand that the side EC and AE is in proportion to BD and DC due to proportionality theorem. So I could actually say this, that AE over EC, that's what we want, is equals to BD over DC. And the reason for this is proportionality theorem. Okay, so whenever you have parallel lines in between your triangle, right, the sides that is created are normally in proportion. Okay, so in this case here, we have AE. AE is 4 over EC is equals to BD, which is 3 over 9. So cross multiplication, you'll get EC is equals to 9 times 4 over 3. That's 36 over 3. EC is equals to 12 units. So that's the answer for A. So for B, it says calculate the length of FG. So to find FG, we need to use similarities. Now, I'm going to focus on two triangles. I'm going to focus on EFG and EDC. Now, triangle EFG and triangle EDC are similar to one another. Okay, so I'm saying that the side, so we need to focus on the sides. The side EF here would be similar to the side ED over here. The side EG would be similar to the side EC over there. And therefore, we could also say the side FG would definitely be similar to the side DC. Now, they're similar, first of all, because the angles are equal, right? This is corresponding, that's corresponding, and this has common angles. So definitely triangle EFG is similar to triangle EDC. Triangle EFG is similar to triangle EDC. So that would actually mean that EF over ED is equals to FG over DC, which is equals to EG over EC. Okay, but I'll only focus on this here. Now, EF, we don't have the actual value, but the proportion, the ratio is 2K, while ED, since this is 2K and 1K, the total will be 3K, right? So this here is 2K over 3K is equals to FG, that's what we're trying to find, and this is 9 units. Okay, FG over 9. So cross multiplying, you have FG is equals to 9 times 2K over 3K. So therefore, FG is equals to 6 units. There you go. And that's exactly what they wanted us to do for this particular question. Question 6. Refer to the cumulative frequency curve below that represents the result of 80 pupils that wrote a test out of 60 marks. Okay, so you can see that on the y-axis is the number of students, number of pupils, and on the x-axis it is the test result. And the first question says, how many pupils got between 12 and 48 for the test? Okay, so to answer this, we need to get our answers from our graph. So we're looking at from 12 to 48. Okay. Yeah, so 12 is here, so this here is 10 students. Then for the 48, yeah, so there will go up to this here. That there is here, which would actually represent 74. Okay, so the first one, as you can see, is 10. So the amount of students would be 74 minus 10, which is 64. So B says if it is given that the lowest mark was 8 and the highest mark was 60, then sketch a box and whisker plot from the cumulative frequency curve on page 12. Now to answer this, if you need to draw a box and whisker plot, you need a 5-number summary, which represents the minimum value, the first quartile, the second quartile, the third quartile, and the maximum value. Okay, that will definitely help you figure this out. Now, the minimum value we've been given as 8, so we have that first one here is 8. The maximum value we were told is 60. We need to guess the Q1, Q2, and Q3. So to find Q1, Q2, Q3, it is 25%, 50%, and 75% of your total cumulative frequency. That helps you get those 3 values. So that's what we're going to do real quick. So using our calculator, 25%, our total cumulative frequency here is 80. So 25% of that would be so that's 20. Okay. So we're going to plot 20 on our graph and see what the corresponding test result is. Plot that in. It connects here. Then draw a straight line down. There you go. So these lines are in 2. So this is 12, 14, 16, 18. So it's between 18 and 20. So I can just call it 19. Okay. So my Q1 is 19. For Q2, it is 50% of my data, right? So 50% times 80, that's 40. So I'm going to go to 40, draw a straight line through it, and connect it downwards. So this is 40. And I'll draw a line there. Then I connect it downwards there. There we go. Okay, so this is 24, 26, 28, 30. So between 28 and 30, I can call that 29. So Q2 will be 29. And finally, for Q3, we'll say that Q3 is 75% of your data, right? So 75% times 80, and that gives you 60, right? So I'm going to 60 right now, right? So I draw a straight line to 60. There we go. I take this and I draw it there. Okay, so I need to connect it downwards. So for 60, we can see that the value is just very close to 36, but it's still between 36 and 38. So I could just regard it as 37. Okay, so the Q3 is 37. Now let's draw a box and whisker. So we're going to have a line at 8. So now each of these divisions is just 1 unit. Okay, so this is your box and whisker. The values that obviously we need to put down is the minimum value here is 8, that's 60, that there is 37, this here is 29, that's your Q2, and this here is 19, which is your Q1. Okay, that's it. For C, they asked you to find the percentage of students or pupils that got more than 60% of the test. Now, the x-axis gives you the test result, but it doesn't give you in percentages. So the first thing you need to do is convert these percentages to the actual mark. So we're going to say 60% times 60, and that there will be 36. So on our graph, we need to draw a line at 36. So if you draw a line, because you see this one is already 37, right? So if you draw a line at 36, it is going to be just below 60, which will be here, right? And that is 59. Okay? So for 59, we'll say that 59 and above, from 59 to 80, are students that have above the 60% mark. Okay, so we will just say that the answer would be 80 minus 59 over the total amount of students times 100%. Okay, that would be the percentage of the pupils that got more. So this here is 21 over 80 times 100. Putting all this in your calculator, 21 divided by 80 times 100, that will give you 26.25. 26.25%. And that's it.